All right. Bismillahirrahmanirrahim. Assalamu alaikum. I hope you all are doing great and you are enjoying the weekend. So, in the previous class, we talked about base units and then the derivation of base units. Today, we are going to move a step ahead and we are going to discuss homogeneity. We are going to discuss homogeneity. Now, in order to move on, we need to know one thing for sure, and that is for an equation to be correct, for an equation to make sense, it must be homogeneous. It must be homogeneous, right? Now, what does that mean? Homo means same. You can see that we have an equation of motion, which is velocity, final velocity is equals to initial velocity plus acceleration into time. This is an equation of motion. Now you can see that for velocity the unit is meters per second. Definitely for the initial velocity it would also be meter per second, and for acceleration it's meter per second square, and for time it is seconds. So I can very clearly see that if I simplify second and second power minus 2, it would turn up to be meter per second. So you can see that meter per second copied down as it is, meter per second for the initial velocity copied down as it is, and meter per second square into second will make it meter per second. So every term in this equation is the same. Every term in this equation is the same. So homo means same. Every term is the same. That means this equation is homogeneous. That means this equation is homogeneous. Now, let's move a step ahead. We need to know that for an equation to be correct, it's necessary that it is homogeneous. But it's not necessary that every homogeneous equation will always be correct. All right. What does that mean? It means that let's say we have these two equations. I have just copied down this same equation twice down over here. One is v is equals to 2u plus 80 and the other one is v is equals to half u plus 80. Now the two equations are the same as over here, just that this u has an added 2 over here and this u has an added half over here. So that means these two equations are not the same as the equation of motion that I have already discussed with you. This is different. This is different. But when you work out the base units, you would find that the base units of each of these terms, the base units of each of these terms is the same. Similarly, the base units of each of these terms is the same. That means these two equations are homogeneous, but you can very clearly see that I have altered the equation. I have added a number which was not the requirement of the equation, which was not the part of the equation. Similarly, I have done the same thing over here. So I have made these equations incorrect, yet they are homogeneous. So homo means same. For an equation to be homogeneous, it's necessary that each and every term in the equation has the same base units. And definitely if an equation is correct, it's necessary that it is homogeneous. But if you work out an equation to be homogeneous, it's not always necessary that it would be correct as well.